Hello, my name is Boris and I'm from Slovak University of Technology. In our work we focus on simulating the process of 3D scanning. Our main goal was to create a simulation that is able to estimate the results of 3D scanning system in its virtual environment. Virtual scanning can be also used for easy data acquisition to test different algorithms. We implemented and compared multiple approaches of virtual scanning, and we also simulated the process of object reconstruction so we could evaluate the precision of the simulation. If you would like to know more, please come to see my presentation. Thank you.
My name is Aljaž and I'm from University of Maribor, Faculty of Electrical Engineering and Computer Science. In this presentation, I will be talking about the suitability of chain codes for near lossless cartoon image compression. A recently published article proved that chain codes are very efficient at compressing cartoon images, and in this presentation I will show you which chain code performs the best. If you are interested, listen to my talk on Sunday at 15:30.
Hello, my name is Vladislav Bari, I'm from FIT-STU and my topic is automatic registration of the medical data. During the registration we need to handle problems like different positions or physiological changes of the patients. If you want to see how we can handle these problems and create automatic registration based on the usage of neural networks, please come see my talk on Sunday.
Hi, my name is Tomáš Bubeníček and my paper is about using game engines to simplify dataset creation for machine learning. If you want to hear some info about why these images show random floating chairs and how we got our datasets generated in Unity to also include path trace output with realistic motion blur and depth of field, and outputs such as object segmentation, optical flow with additional occlusions information, motion segmentation, depth output, bounding box positions, and much more. Tune in today during the Vision blog for more info. Thank you.
Hi, I'm Richard Todt and I'm going to present you a method how to improve your 3D scans. So you just ordered a brand new scanner from Amazon and you are ready to go, but you just realized it only creates 3D points in space and it's boring. Never mind, use our solution to create virtual surfaces in real time to be the coolest in the neighborhood. But wait, there is more! Try out our new subsurface scattering module to improve your scans, and all that still in real time. Thank you.
Hello, my name is András and I am from Budapest University of Technology and Economics. I'm going to present an optimized and flexible G-buffer structure for deferred renderers with multisample anti-aliasing. It requires less GPU memory than previous approaches, while still offering the same anti-aliasing quality and better performance for most scenes. If you are interested, then please come to my talk at the real-time graphics session. Thank you.
Hello and welcome, my name is Stefan Stappen and today I'm going to present you Spatial Temporally Filtered Adaptive Shading, STEFAS. In computer graphics we waste a lot of processing power by computing the color value of each pixel every frame. And as you see here in the blue regions, this is not necessary because we reduced here the shading resolution and still get the same results. STEFAS does this by computing the over and undersampled regions over time and adapting the shading rate accordingly. And we achieved a performance improvement up to a factor of 4 with this. If you're interested how we achieved this, come and watch my talk. Thanks.
Hello, my name is Jaroslav Kravec. I'm from Czech Technical University in Prague. Now I will show you a technique for real-time remote rendering and streaming to thin clients. Our primary focus is to provide good VR experience. This means high frame rate and immediate effect on the rendering of head movement. The server streams geometry and image data and the clients achieve higher frame rate by rendering it multiple times but with current camera position. It is frame rate upsampling technique which also reduces perceivable latency. We use real-time ray tracing on the server. If you are interested, come to visit my talk.
Hello, my name is Nikolas Hamran. I am from the Slovak University of Technology and my topic is on the accelerated curve skeleton extraction with GPU computing. The curve skeleton is a useful structure, but usually it takes a lot of resources to obtain it. Since GPU computing is becoming very popular, we decided to approach this problem from a new perspective. To see how we did it, come to my talk on Monday.
Hi, my name is Alexander Weinrauch and I'm from Graz University of Technology, where we developed a novel REAP graph-like structure called natural REAP graphs. Natural REAP graphs contain important topological information about the shape, including loops, handles or holes. We create them by analyzing a natural diffusion process on the surface, which is done entirely on the GPU. We can then also easily embed our graphs into the mesh in form of a skeleton, as can be seen on the right. If you're interested in the more details of our approach, join my talk on Monday at around 9 AM. Thank you.
Hello, my name is Thorsten Kopic. I'm from the Technical University of Vienna. I'll be talking about 3D mesh unfolding and how to optimize it. So if you're interested in a novel meta-heuristic approach on how to unfold 3D meshes and additionally assign glue types to make it easier for users to reconstruct the model, then I'll be happy if you visit my talk.
Welcome, my name is Florian Komposch and in my talk I will present a method to introduce skeletal animation into a shading atlas streaming environment. Shading atlas streaming is a decoupled rendering solution to enable high-quality virtual reality experiences on remote devices. I will give an overview on the streaming technology and then present our method to introduce animation into the decoupled interactive real-time environment. If you're interested, I'm looking forward to see you in my presentation on the May 4th.
This paper presents a fluid manipulation technique. We use triangle meshes to influence fluid behavior, including shaping, animating, morphing and dissolving liquid bodies, while keeping the physically trustworthy features of the fluid simulation. Our method is based on smooth particle hydrodynamics, and quantities are applied to control particles computed from the triangle mesh models. We show the results using petaball array matching accelerated by per pixel fragment list on the GPU.
Hi, I'm Monica from the VIAVIS Research Center. Have you ever experienced a user interface that was so laggy that the experience was underwhelming? I'm sure you did. That's why we decided to implement a tool that not only handles a big amount of data in a smooth, interactive way, but also helps in decision making. In my talk, I will show you how to achieve performance with the help of the Elm architecture, functional programming paradigms, and incremental data structures.
Hello, I'm Alexander from the Technical University of Graz, and I will show you a web application for applying inpainting on medical images. On the CT scan in the video, a dissected aorta can be seen inside the marked region. By inpainting, it is possible to generate image pairs which can be used to study the origin of this disease. By using the presented tool, this can be done directly in the browser without any additional software. I invite you to join my talk to find out more about such a real-world application of inpainting.
Hi, my name is Jana Poláková and I study at Slovak Technical University in Bratislava. The purpose of my work was to examine the depth perception in virtual environments. We performed an experimental eye tracking study in a laboratory with 37 participants. The experiment results showed the presence of the so-called pop-out effect, and we revealed a tendency of people to fixate either the closest or the farthest objects at the scene the most often.
Hi everyone, we're from the Faculty of Electrical Engineering at the University of Sarajevo. We've worked on using augmented reality for representing historical monuments throughout their past. If you want to find out more about how we did it, tune in on our presentation on Monday, 4th of May at 1 o'clock. See you then.
Hello everyone, my name is František Divena and I will talk about the evaluation of 3D model reconstruction in virtual reality. Many of us know the pipeline of 3D model reconstruction from scans, but the question is how to evaluate the quality of reconstructed output, especially when the ground truth model is not available and we can compare numerical characteristics. In this case, using virtual reality can be very beneficial. So, if you want to know more, please join my talk.